Hi, I'm Michael Osman of Great Scott Gadgets, and this is Software Defined Radio with HackRF, Lesson 5, HackRF 1. Most of this course is about software defined radio, but this lesson is about HackRF 1, the hardware platform. HackRF 1 comes in a cardboard box, and inside the box you should find a USB cable and HackRF 1 itself. Now, HackRF 1 has a black plastic injection molded enclosure, and at either end of the enclosure you'll find all these various things. And I'd like to go through these things one at a time so you understand what they all mean and how to use your HackRF 1. Now, the most important thing you need to know is the USB connector. It's a USB micro B connector, and the reason it's most important is because HackRF 1 is powered by this connector, so it doesn't do anything unless you plug in a power source. I'm going to plug it into my host computer, and you should see that some of these LEDs illuminated. Let's go through these LEDs one by one and talk about what each one means. The first three LEDs that you should see illuminate when you first plug in HackRF 1 are 3V3, 1V8, and RF. And those are three different power supplies within HackRF 1. Normally they should all three come on when you first plug in HackRF 1 to a power source, and under normal use they should all remain on. The only reason a couple of them might turn off would be if we implement a low power mode, a power saving mode. And then while the HackRF 1 isn't doing anything, you might see a couple of those turn off. But if you're trying to use HackRF 1, if you're trying to receive or transmit radio signals, then all three of those should be on, and if they're not all on, then that indicates a problem. Now the next LED is called USB, and that indicates that the host computer is actually talking to HackRF 1. They're communicating over USB, and the host computer has configured HackRF 1 as a USB device. So you might notice that the USB LED illuminates just a little bit after the first three. The first three LEDs should turn on very quickly when you plug in the USB connector and power on the HackRF 1. The USB LED might come on a second later because that doesn't happen until after the USB host has configured HackRF 1. And then the next two LEDs, which should be off when you first plug in HackRF 1, are labeled RX and TX. RX indicates a receive operation, and TX indicates a radio transmit operation. So you should see one of those turn on when you're actually using HackRF 1 to receive or transmit a radio signal. So most of the time while you're trying to use HackRF 1, you should see four LEDs illuminated, the three power supply LEDs and the USB LED, and then you should only see the RX and TX LEDs illuminate when you're in the middle of a radio receive or transmit operation. Now those last three LEDs, USB, RX, and TX, are under software control. They're controlled by firmware running on the microcontroller within HackRF 1. So if you were to install your own custom firmware, you could use those three LEDs to indicate whatever you want. But using the default firmware that most people will be using most of the time, those indicate specifically USB configuration, receive mode, and transmit mode. Now you might notice that all six of these LEDs are various colors, and the colors don't mean anything. The only reason they're different colors is so that you can distinguish one of these LEDs easily from its neighbors. Each of these LEDs is a single color LED, and there are various colors across the row. Now, the other two things you might notice near the LEDs are these blue buttons, the reset button and the DFU button. The reset button resets or reboots the microcontroller within the HackRF. One way you can reset HackRF, of course, is to unplug the USB power supply and then plug it back in. But it's a lot more convenient and easier on the USB connector if you just press the reset button briefly. That reboots HackRF, and it will reset, so the host computer has to reconfigure it on the USB bus. It's kind of like what happens when you unplug the power supply and plug it back in, but it's quicker and easier to press the button. The other button is labeled DFU, and that's used for firmware update mode, but you don't actually need to use it most of the time. HackRF 1 is able to update its own firmware without having to go into DFU mode. The reason we support DFU mode is because that's a way that you can unbrick a HackRF if you have a firmware update that went wrong. If for some reason your HackRF does not actually enumerate on the USB bus and you never see that USB light come on, then that might indicate there's a problem with the firmware. And if that happens after you tried to do a firmware update, well, then you can use DFU mode to recover your HackRF. And the DFU bootloader is actually in ROM, so it can't be overwritten. Now, to get it into DFU mode, what you do is you hold down the DFU button while unplugging the USB connector and plugging it back in. Actually, what really matters is that you're holding the DFU button down while you plug in the power supply. And if you do that, you should notice that the 3v3 LED comes on, but the other two power supply LEDs don't come on, or at least they don't come fully on. And that's a good way to check that you're actually in DFU mode just very quickly. The other way to get into DFU mode is, I'll just reset it here so now it's in normal mode. The other way to get it into DFU mode is to hold down the DFU button while you press and release the reset button. Then you can release the DFU button, and now HackRF 1 is in DFU mode. Either way, whether you hold down DFU during a reset or if you hold down DFU during initial power on, then HackRF 1 will start up in DFU mode, which is using a ROM bootloader, and you can use a special piece of software on your host computer to actually install HackRF firmware on HackRF 1, even if there is no currently functional firmware on the device. Now, I'll just press reset again, and it should actually reboot the regular firmware and be back into the normal mode. The DFU button doesn't actually do anything except during reset or during initial power on. So it is available to you if you are interested in making your own custom firmware for HackRF 1. You could actually use that DFU button as an input to your firmware because it doesn't do anything normally. It's only during reset that it matters by default. Now, the other thing on this end of HackRF 1 is the antenna port, and on the other end we have these two ports, clock in and clock out. All three of these are similar connectors. Let's take a look at them. They're SMA connectors, and they come with these red plastic caps that are protective caps. It's a good idea to leave those on if you're not using the port. So for example, these clock in and clock out ports I don't use very often, so I usually have them covered by the red cap. These are SMA connectors, all three of them. And you might have seen similar connectors on Wi-Fi equipment, for example. It's very popular on Wi-Fi equipment to have RP SMA. Now, RP SMA is different than SMA. SMA has a female connector, that is the connector with external threads. The threads are on the outside here. The female connector, if you look inside, has a female connection in the inside, and then the other connector that mates with this one has a male pin in the middle. And an RP SMA connector has them the other way around, so the female connector, or the one with the external threads, actually has a little male pin inside. It's a little bit confusing that they have these two different styles of connectors that are almost identical, except they change which side has the pin internally. So be careful that when you're selecting equipment or antennas or cables to plug into the connectors on HackRF 1, be careful that you use SMA connectors and not RP SMA connectors, because an RP SMA might appear to actually connect correctly, but there will be no internal connection because neither side will have a pin. And that's a very annoying problem to have because it can be hard to troubleshoot because it looks like everything's connected, but then there's no actual internal connection. So be careful of that. Now the SMA connector here that's labeled antenna is the antenna port, or you can think of it as the RF port. You don't have to connect an antenna to it, but you should have it connected to either an antenna or a cable going to some other RF equipment. One antenna you might use is ANT 500, which is just a simple telescopic antenna. This is a good starter antenna for HackRF, but realize that there's no one antenna that is good for every application that you might use HackRF1 for. This is just a good antenna to get started because it is very simple, telescopic, and because it's telescopic, it can operate over a pretty wide range of frequencies, and it has an SMA male connector that allows you to connect it directly to the HackRF1 without any adapters. So be sure that you do have an antenna or something connected to the HackRF at all times when you're doing receive or transmit. Now, if you're ever tempted to not have an antenna connected at all, what you should do is get one of these little dummy loads. And this is just a little SMA male plug that has a 50 ohm load within it. This just screws right on the SMA connector, and it allows you to use your HackRF1 safely even with no antenna attached. So that's very important. Never use your HackRF1 for receive or transmit without having something connected to the RF port. It should be a dummy load or an antenna that is suitable for the frequencies that you're working with, or a direct connection to RF equipment. Now, if you are using a direct connection to RF equipment, be aware of the maximum input and output power levels that you can find on the HackRF wiki. It's very important that you don't exceed those limits or else you might damage the HackRF1. Now, the other two ports on the other end, also SMA connectors, are clock in and clock out. And these are for clock synchronization between multiple HackRF1s. So, for example, you can take two HackRF1s, take an SMA cable and connect it from the clock out of one HackRF1 over to the clock in on the other HackRF1, and then their clocks will be synchronized, which is useful for certain applications. Now that only matters if you have multiple HackRF1s, or if you would like to take your single HackRF1 and would like to synchronize it to a particular external time source. For example, you might have a GPS disciplined oscillator, or you might have a rubidium frequency standard, or something in your lab that provides a more stable clock source than the crystal that's within HackRF1, for example. And if you do, all you have to do is take a 10 megahertz signal and connect it to the clock in, and the HackRF1 will automatically synchronize to that external clock. It's always looking every time. Actually, it's when you start a receive or start a transmit operation. Every time you start an operation, a radio operation with HackRF1, then it checks to see if there is a 10 megahertz signal on the clock in port, and if there is, it synchronizes to that signal, and if there isn't, it uses its own internal crystal. Now, the signal that you need to give it on the clock in port is a 10 megahertz square wave ideally, and it should vary between about 0 volts and about 3.3 volts. So it's a 3.3 volt square wave, and that's exactly what you should see on the clock out port of every HackRF1. So you can connect them directly together from one clock out to the other's clock in, or you could connect one or more HackRFs. You could take their clock in and connect them to a single source, a single time base for all of them. Most of the time, for most applications, I don't use those ports, and so I just leave the red protective caps on those SMA ports, and I don't worry about them. Now, let's talk about how to use HackRF1 a little bit, and a little bit about the software that is available for HackRF. The HackRF project provides two different software packages, and they are called libHackRF and HackRF Tools. Now, libHackRF is a library that allows other software to communicate with HackRF. So for example, this is how GNU Radio communicates with HackRF, is through libHackRF. HackRF Tools is a small software package that provides some command line tools for working with your HackRF. Let's get familiar with those a little bit. The first command you should know is HackRF info. And if your HackRF is plugged in and you type HackRF_info, you should see that it finds that HackRF unit and it tells you that it's a HackRF1 and it tells you the firmware that is installed. In this case, it's 2014.04.1, which is from a release package. You might see that your firmware says git something or other, which is telling you the particular git commit from the source code repository. But if you install firmware from one of the release packages, then your HackRF1 should tell you when you use the HackRF info command that it is running that particular release. Now, the next command I'd like you to know is HackRF transfer, and I'll just type it here and show its help output. There are quite a few different options. Now, this is a small utility that you can use from the command line to transmit or receive data. So if you receive if you turn the HackRF1 on into a receive mode using the HackRF transfer command, then data will stream over the USB connector and into a file that you specify. And if you use transmit mode, the -T option, then you will specify a file name and that the data in that file will be streamed over USB to the HackRF and then turned into a radio signal out the antenna port. Now, there are a whole bunch of different options here for configuring the radio section and turning on different gain stages and all sorts of different things. But let's try this out a little bit. And I'm going to type HackRF_transfer, and I'm going to tell it to do a receive operation and put the data into a file called /dev/null. And if you're on a Linux system, you should always have a file called /dev/null. It's a special file and that just throws away everything that you give it. So this is just a quick test to make sure that our HackRF can transfer information to us. Let's give this a try. Now, it says stop with Control-C, so that's what I'm going to do in a few seconds here. I'll just hit Control-C, and I'm done. Now, you should notice that the default sample rate that it set to was 10 million hertz, or 10 million samples per second. And I got an average of 20 million bytes per second from the HackRF. And that's normal. You should see 2 bytes transferred for every sample, because a sample is made up of two values, each of which is a signed 8-bit integer, or a signed char. And that's the actual data format that's used over the USB connection of HackRF. And so the HackRF transfer utility is just a simple way to take the raw data that comes over USB and put it into a file, or to take data from a file and transfer it over USB to the HackRF. So in this case, we just verified that everything was working correctly. All the HackRF digital section is working correctly and giving us 10 million samples per second. And if we want to, we can change the sample rate using the -S parameter. For example, if you wanted to find out, does your USB connection on your host computer actually support 20 million samples per second? If you type -S 20 million on this HackRF transfer command, now we'll be operating at 20 million samples per second, and we should see that we get an average of 40 million bytes per second, because that's 2 bytes for every 1 sample. And sure enough, on my particular computer, on this particular USB port, I can get that 40 million bytes per second, and that means that HackRF is able to operate on this computer at its maximum sample rate of 20 million samples per second. Now that's the advertised maximum sample rate, but I found that on at least some host computers, and with some HackRFs at least, I am able to operate at 21.5 million samples per second. And if you do that, you should see that you're getting 43 million bytes per second. That's the absolute maximum, pretty much, that I've seen work reliably on any host computer. Now, some host computers won't be able to operate that fast, and it could have to do with the speed of the CPU, but more likely, if you're just using the HackRF transfer utility like this, more likely that would indicate that there's a problem with the USB connection itself. The USB host controller within the PC might not be able to operate that fast, or there might be other USB devices on that bus inside the PC that you can't see, and they may be slowing down the available throughput for HackRF. So you might find, and this is a good way to find this out, you might find maybe your particular USB port only allows you to operate up to 16 million samples per second. And HackRF transfer utility is an easy way for you to find this out. And it's a good way to find it out because it is only exercising the USB connection. If you are writing the samples to /dev/null, then you're actually not saving the samples anywhere. You're discarding them, and so you're not requiring your CPU to do anything with those samples. So it makes it it isolates any problems you might have with the USB connection from problems that you might have with your CPU keeping up, and it allows you to determine exactly how fast your USB connection is able to go. Now, personally, I've had computers, I've had a laptop, for example, where on one USB port I could get 20 million samples per second, and on a different USB port I was only able to get 16 million samples per second. You may have various different maximum rates that you find that different USB hosts are able to achieve. But in general, you should, unless you're trying to connect to a very busy USB port, or you're connecting to a port that's broken or doesn't support high-speed USB, as long as the port that you're connecting to is functional and not too busy, you should be able to get at least 10 million samples per second, which is the default transfer rate with HackRF transfer. You should be able to get at least 10 million samples per second with pretty much any USB port. And the HackRF transfer utility is a way to verify that. Now, again, I want to look at the options here just a little bit. If we did the same thing, only use the -t, transmitting /dev/null doesn't make any sense, but you could transmit dev0, for example, or you could transmit data from a file. And the data format, as I mentioned, is two 8-bit signed integers for every sample. And we'll talk about why there are two integers per sample in the next lesson quite a bit. Now, there are a number of different command line switches, like setting the frequency, and if you want, you can use these options to set the intermediate frequency, the local oscillator frequency, and the image reject filter selection. Normally you wouldn't do that. This is just a way to kind of override the default tuning algorithm that's within HackRF1. In the future, we'll talk more about the internals of HackRF1 and what these exact options mean and what they do inside HackRF. Most of the time, you should use the -f option to set the frequency. Now, the amp enable option enables the RF amplifier. Notice it says RF amplifier. And so you might have noticed, for example, in the Osmocom source in GNU Radio, there is a RF gain setting. And that RF gain setting we set to 0 dB, I think, when we were doing an example the other day. Now, in HackRF transfer, you can notice that this is actually set to either 1 or 0. You either enable or disable the RF amplifier. There are only two settings for that particular gain stage, and that's the stage that's closest to the antenna. And so normally, and nominally, that gain stage gives us about 14 dB of gain, although the amount of actual gain varies by the frequency range. So if you set that to, I think, 10 dB or higher in the Osmocom source, then it will enable the RF amplifier. If you set it to 0 in the Osmocom source, it will disable it. Now here with the HackRF transfer utility, we simply type -A0 or -A1 to enable or disable that gain stage. There's also this antenna port power control. Now normally antenna port power is off, which means there's no DC on the antenna port. There's no direct current power supply there. But it's possible to enable a small amount of power on the antenna port. That could allow you to use an active antenna, for example, like there are GPS antennas that are compatible with HackRF1 that can be powered by HackRF1 if you use this option. And then we have these other gain options, and these are different gain stages, and these relate to the other gain options that you might have noticed in the Osmocom source in GNU Radio. -S lets us set the samples per second. -N lets us transfer a particular number of samples. So if you only wanted to transfer 1 second, for example, and you were operating at 10 million samples per second, then set this to 10 million. Otherwise, it'll just continue until you hit Control-C. And this -C option is new. It lets us transmit a CW signal, or just a constant carrier, which is useful for various testing states that you might want to put the HackRF in. And the -B option lets us set the baseband filter bandwidth. We're going to talk about that more in the future, and this is also something that you can control from the Osmocom source in GNU Radio. But the default, notice, is less than the sample rate in hertz. So whatever you choose for your sampling rate, it's going to automatically select the filter, the baseband filter that is just slightly under your sample rate. So that's the default, and normally that's fine for most applications. But we'll talk in a future lesson more about when you might want to use a different baseband filter value. Now, the other utilities that are good to know are the utilities that are used for updating the firmware in HackRF. Now, if you type HackRF info, you'll see the firmware version that is installed on your HackRF. And in this case, this one has 2014.04.1, and that's not actually the most recent version that's available. The most recent version available right now at the time that I'm recording this is 2014.08.1. So let's update the firmware. Now, I'm going to use a copy of the release package, and this is actually a file that I've downloaded. That is the release package for HackRF. Now, if you're using the Pen2 ISO, the most recent version that's coming out right about now actually has the contents that we'll need on the ISO itself, so you won't have to download the release package. But you can always download the release package, the most recent release, and find the files that you'll need for doing a firmware update. So I'm going to extract this HackRF release package and look at the contents here. I'm going to go into the firmware bin directory. These are the firmware binaries, and you can see that there are some firmware binaries for HackRF1 and some for HackRF Jawbreaker, which is the beta platform. And then there's also this CPLD configuration file that we'll work with in just a moment. The first thing I'd like to do is to use the HackRF Spy Flash utility. This is another tool that's part of the HackRF tools package. And I'm going to write to the HackRF the file HackRF1 USB ROM to RAM.bin. So just remember that ROM to RAM. And the reason it's called ROM to RAM is because we write this file to the flash that is on the HackRF, and then when it boots up, it actually copies it from flash to RAM and then executes it. So this particular binary has the code in it that allows it to load itself into RAM, as opposed to this other one, which only is for use during recovery operations using DFU mode. So I'm going to write this file, And it only takes a few seconds. Now it's done. Now if I type HackRF info, you should see I'm still running the old firmware because I haven't rebooted the HackRF one, and I haven't gone through that process of copying, having the firmware copy itself into RAM and execute. So I'm going to hit the reset button on my HackRF one, and now if I type HackRF info, look at that, I'm running 2014.08.1. That's how easy it is to update the firmware. Now there is one other step though that you should take, and that is updating the configuration of the CPLD. That's the complex programmable logic device on HackRF1. Remember there's this other file here, HackRF CPLD default. Anytime you see an XSVF file, that is a configuration file for the CPLD. And this is, the CPLD is a chip on HackRF1 that is between the microcontroller and the analog to digital converter and digital to analog converter. And it provides some interface functions in between those two. And from time to time, there may be a new version of the CPLD configuration that comes with a particular release of HackRF software. So, in this case, there is one. So I'm going to run the HackRF CPLD JTAG utility with a -X option and give it a HackRF CPLD.xsvf, and I will run this, and it tells me to wait until write is finished, and sure enough it tells me write is finished, and it's telling me to power off and disconnect the HackRF. Now in the future this may actually reboot itself when we do a CPLD update. It might reboot itself when we do a HackRF SPY Flash update. But right now, in both cases, I have to reset the HackRF to actually activate the new code. So now I've reset the HackRF, and if I run HackRF info, it tells me the firmware version. Note that it does not tell me the CPLD version. So it's very important that you do update the CPLD to the latest version when you update the SPY Flash or the actual firmware to the latest version. You have to remember to do that. So do both, and you'll have your HackRF running the latest software, the latest firmware, and the latest CPLD code, and that will go along with the latest software that you have installed on your host computer. I'll save an in-depth discussion of the internals of HackRF1 for a future lesson, but I hope that getting familiar with the externals and with some of the software that's available for HackRF was useful for you. It can certainly be useful to use those command line tools for troubleshooting your HackRF1 or for performing firmware updates. Now there's one thing about the inside of the HackRF1 that I would like you to know about right now, and that is the RF amplifier that I mentioned when we were looking at the HackRF transfer utility. Now the RF gain stage, or the RF amplifier, is right next to this antenna port. It's right here. And there are actually two RF amplifiers. There's one for transmit and one for receive. And then there's a third path that just is a bypass path that allows you to completely bypass those amplifiers and operate either in receive mode or in transmit mode without that amplifier active. So if you set that amplifier setting to 0, or if you set RF gain to 0 in the Osmocom source or sync in GNU Radio, then you will disable that amplifier stage completely. And that's how I recommend that you operate most of the time, unless you need that extra boost for a particular application. And the reason I want you to know about it in particular is because it's right next to this antenna port. There's no filter between the antenna port and that gain stage. So for example, if you were receiving FM radio stations in GNU Radio and you turn that amplifier on, and you happen to be in close proximity to a high-powered amplifier running at, say, 2 gigahertz, completely different frequency than the FM radio stations that you're trying to receive, that RF amplifier stage is actually receiving that 2 gigahertz signal and trying to amplify it before it gets filtered out later in the receive chain in the HackRF. So be aware of that. that you could potentially overpower a gain stage. You could potentially damage an amplifier in that gain stage if you don't, if you're unaware of that, and if you were to exceed the power limits of HackRF1. So some tips just to keep your HackRF1 safe. Be sure that you always operate with an antenna connected, or a dummy load connected, or a cable to some RF equipment connected. And usually if you do use a cable, you'll probably have an attenuator that you'd want to put in place. Be sure to check out the wiki and look at the power limits of HackRF, and that way you'll know how much attenuation you might need when you directly connect equipment to HackRF. But if you always use an antenna or a dummy load, and you're careful, and you don't activate that gain stage except when you really need it, then your HackRF should last quite well, and everything should work. But the most sensitive part that you should probably be aware of is that gain stage right by that amplifier. So be aware of that, and I hope to see you next time for Lesson 6.